All right. Today we're going to talk about factoring polynomials. Our objective here is to factor polynomials by using the GCF, or greatest common factor, by recognizing special products, and by grouping terms. All right, so let's start off with an example here. Let's say I have 2x to the fourth. So we've got 2x to the fourth minus 4x cubed plus 8x squared. All right. So I'm going to start off by looking at the coefficients. I got 2, 4, and 8. All right. Fairly obvious that the greatest common factor for 2, 4, and 8 is going to be 2. So whenever I find the greatest common factor that is other than 1, I want to factor it out. So let's say we at least have a 2 here. So I'm going to factor that out. Now I'm going to look at the x values. I've got x to the fourth, x to the third, x squared. Greatest common factor is going to be x squared. So my GCF for this whole expression is going to be 2x squared. Now, I'm going to factor that out of our original expression. So I take 2x squared out, and what's left is going to be x squared minus 2x plus 4. All right? And so here is a case where we have factored out the GCF. Let's look at another example here. Let's say we've got 10 AB to the third, 10A B to the third, minus 15a squared b squared, minus 15 a squared b squared. All right, I'm going to look at the coefficients. I got 10 and 15. Greatest common factor for 10 and 15 is obviously going to be 5. So I'm going to be taking a 5 out. Now look at the a's. I got a to the 1, a squared. So the greatest common factor of those is going to be a. Now I look at b. I got b to the third, b squared. Greatest common factor, b squared. All right, so that's the GCF. So I'm going to factor that out. And what do I have left? So if I take 5ab squared out of the first term, that leaves me with 2b. And if I take 5ab squared out of the second term, that leaves me with 3a. So once you factor the greatest common factor out, you got 5ab squared times 2b minus 3a. All right. Once you've checked to see if you can factor out the GCF, you can look to see if you have any special products. Now, we talked about these earlier, but we're going to talk about them again now. I want to repeat them for you now. And that is when we got perfect square trinomials. So if I got something like a squared plus 2ab plus b squared. If I factor that, that is simply a plus b quantity squared. So that's the first of our perfect square trinomials. Similarly, if something looks like this, very similar, just a sign change, say I've got a squared minus 2ab plus b squared that is equal to a minus b quantity squared. And you can FOIL these out to prove that they indeed are what I say they are. And then the third is probably the one that people recognize the most easiest, and that is if you've got the difference of squares. So say you get a squared minus b squared. A squared minus b squared, and that is simply equal to a plus b times a minus b. All right, so these are three special products that you should learn to recognize. So let's look at some examples here. All right, so let's say I've got z squared plus 6z plus 9. So I've got, here we go, z squared plus 6z plus 9. All right, if we look at that closely, this is simply z plus 3 quantity squared. This is a perfect square trinomial. So this is equal to z plus 3 quantity squared. Okay? Because 3 times 3 is 9, and 3 plus 3 is 6. All right? Let's look at another one here. Let's say I've got 4s squared minus 4st plus t squared. And if we look at this closely, what is this? This is actually, and I could rewrite this as 2s quantity squared minus 2 times 2s times t, by the way, those are s's and not 5s, plus t squared. And again, if you look at this carefully, you'll realize this is another perfect square trinomial. This is 2s minus t quantity squared. Okay? And we'll do one more example here. Let's say we've got 25x squared 25x squared minus 16a squared. Now, notice I don't have 3 terms here. I've got 2 terms separated by a minus sign. Well, anytime you see 2 terms separated by a minus sign, you should ask yourself, are these 2 terms perfect squares? And the answer is yes, they are, because the square root of the first term is 5x, the square root of the second term is 4a. So this is simply difference of squares, and if you were to factor it, it would be 5x plus 4a times 5x minus 4a. Difference of squares. All right, now sometimes we might need to use more than one method to factor a given polynomial. So let's look at another example here. Let's say we've got 3x to the fifth minus 48x. So what do we got here? 3x to the fifth minus 48x. Now remember, the first rule in factoring is to look if there's anything common, or look to see if you got a GCF greater than 1. All right, if I were to look at this, look at the coefficients first. I got 3 and 48. Well, it's pretty obvious that 3 is the GCF for those, and then I got x and x to the fifth, so therefore my GCF in this case is 3x, okay? So I'm going to take the 3x out, and what's that going to leave me with? That's going to leave me with x to the fourth minus 48 divided by 3 is 16. All right? Okay, now, so I got the 3x out, but what's in the parentheses? X to the 4 minus 16. Two terms separated by a minus sign. Ask yourself, are these both perfect squares? X to the fourth, the square of x to the fourth, square root of x to the fourth is x squared. The square root of 16 is 4. Yes, this is the difference of squares. So therefore now I can continue factoring and say that this is equal to 3x times x squared plus 4 times x squared minus 4. Well, notice, again, I've got two terms separated by a minus sign. X squared minus 4. Are both x squared and 4 perfect squares? The answer is yes, so I can factor these. And now what do we end up with? We end up with 3x times x squared plus 4 times x plus 2 times x minus 2. And here we've completely factored our original expression. All right, we have another set of special sequences here, and that is the sum and difference of cubes. So let's say I had a cubed plus b cubed. So I got a to the third plus b to the third. And that is simply equal to a plus b times a squared minus ab plus b squared. So that's the sum of cubes. Difference of cubes looks very similar. a cubed minus b cubed. That's now equal to a minus b. Very similar to the above, the only difference is a couple of signs. Times a squared plus ab plus b squared. So here are sum and difference of cubes. All right, so let's look at an example here. And we obviously could have either one, but this example is going to be y cubed minus 1. So I got y cubed minus 1. This is obviously difference of cubes, so this is equal to y minus 1 times y squared plus y plus 1. Okay? And similarly, if I had 8u cubed plus v cubed, this is the sum of cubes, so because 8 is a perfect cube, so therefore this would be 2u plus v times 4u squared minus 2uv plus v squared. Difference in sum of cubes. All right, our last example is simply going to be factoring by grouping, okay? So let's look at an example here. Let's assume we've got 3xy minus 4 minus 6x plus 2y. Now if I regroup these and I rewrite it in this order, 3xy minus 6x plus 2y minus 4 okay. I notice that the first two terms have a common and the second two terms have a common. So let's look at the first two terms. I notice I can factor a 3 out and I can factor an x out. So this becomes 3x times y minus 2. In the second two terms, I notice I can factor a 2 out. And that leaves me with y minus 2. All right, so therefore I got y minus 2 that's common in both, so that I can factor the y minus 2 out. And what's left is 3x plus 2. Factor by grouping. All right, lastly, I'd like you to do problem number 21 of the oral exercises on page 185 and post your answer in the Dropbox. Thank you.